Thanks for coming, guys. Tonight I'm going to talk about DropWizard. We ended up picking 0.7.1, so everything that we've looked at pertains to that version. There are newer versions around, so things may have changed since we did this analysis. So a quick intro. Thank you very much, Con. Really appreciate the kind words. My name's Pocklington. I've been a full-stack developer my whole career, about 12 years. I've been using Java since I started university, so it's a long time. I've looked at Scala and I used that for 6 months and I hated it. That's just my personal opinion. I've used Groovy for 2 years and I loved it. So that's me. So I'll just go into an overview of what my talk's going to be about. First, I'm going to set the stage and explain why I came to DropWizard and how that fits into my daily job. I'll talk about DropWizard from 50,000 feet as an overview. I'll discuss how to run it locally and how it feels, how it works. Talk about how it deploys compared to other traditional apps. How to do testing. And finally, I'll summarise some of the strengths, some of the weaknesses, and I'll also touch on some performance. So we did some performance analysis compared to a few different stacks. So what we considered in our company, because we're doing a Greenfields project, was what stack do we use? We knew we wanted to do a web framework on the front end, but we weren't sure what we wanted to use on the back end. So we asked, what's our stack going to be? And they said, work it out. So really had kind of free rein, at least to analyse what was out there and sort of come to some sort of conclusion, which doesn't happen often these days. Normally you get told what stack to use and that's it, you can't argue about it. So this is the first time I've been offered to look into this. So we sat together and said, right, what are our evaluation goals? We want it to, in our proof of concept, we want to be able to write and run code and feel how it works, how quick it works, if there's any gotchas, as you would when you're doing stuff day to day. We also want to write and run tests because sometimes writing tests can be complex depending on the environment, and that kind of hints at how complex the framework can be and how much magic is in there and how you go about overriding defaults and stuff like that. We wanted to work out how to package and run an artifact, so with the aim of being production, how difficult would that be to set up and automate? There's automate. And also how to debug. So when you've got something you don't understand, you don't always write a test for, you want to be able to dive in there and debug it locally. So we wanted to make sure that was easy and that enabled devs to find problems quickly. And we wanted to performance test it. Ultimately, this is going to go to prod. It may be in a high volume circumstance. So we want to be able to have an idea of what the load graph looks like in terms of memory, CPU, and response time. And at the end, we wanted to give a presentation back to the team of devs and at the end make an objective choice and move on. So there was a few things we didn't consider as part of this spike. So some of them were complex authentication. We didn't need it for this particular product, so we kind of ignored that aspect. We didn't need complex orchestration. We didn't need to call out to multiple endpoints and orchestrate that flow of data. So we didn't look at that either. We didn't need large units of work per request. So think of your typical kind of CRUD apps or smaller / microservices. We just wanted to do simple things per request and have it be very transparent. So we didn't look at things like large batch operations. We looked at all the frameworks out there and we decided things like Vertex, Play, Grails, traditional Spring MVC and struts weren't going to be in this review. Nor JBoss, J2EE and WebSphere. So at the end of the day we came to 3 stacks. We looked at, or 4 actually, we looked at Ruby on Rails, we looked at Spring Boot, DropWizard obviously, and Node.js. So we made a few things for our wish list. We wanted to be productive. We wanted it to be in Java 8 if it was on the JVM. We wanted it to have simple ways to validate data coming in, simple ways to validate things like strings and ints and dates, and also more complex validation like logic. We wanted a good separation of concerns. We wanted it to be easy to bring people on board and not have to explain every little detail. A framework like Rails does this really well with their convention. We wanted database integration. We were definitely talking to a database, so we wanted to make sure that was really easy and easy to integrate with, write tests for, and do database migrations. And we wanted the test framework support to be good. And lastly, to Con's point, we wanted to support Maven or Gradle because they're the main two contenders in the build systems of Java. As a bonus, if we can have it, we would have liked to see API docs, metrics, and health checks built in. These are some of the more modern things you get in JSON APIs these days. So from 50,000 feet, what is DropWizard? I'll tell you what DropWizard isn't. DropWizard does not come with Hibernate by default. You can add it in. It doesn't come with Spring. You can add it in again. It has no dependency injection. So if you're used to using Spring MVC and doing auto wiring and stuff like that, this is a little bit of a departure. It is a bit of a sidestep from what you're used to, but it kind of brings it back to simple stuff. And to be honest, I don't really feel like we've lost a lot of stuff by not using dependency injection. However, there are advantages. So what is DropWizard? It's a combination of well-chosen frameworks and libraries. So you've got Jetty for HTTP, you've got Jersey, you've got Jackson for JSON, and Hibernate validations. You've also got JDBI, which is kind of a thin layer on top of JDBC, but it gives you much more fine-grained control than something like Hibernate. And it comes with Liquibase out of the box for doing database migrations. So in DropWizard, the end artifact is packaged as a single jar, and it comes with its own public static void main method, which I haven't seen in quite a few years. All right, so running it locally. It takes about 5 to 10 seconds to start up on a good Mac. I can't actually demo the code to you today, unfortunately, but you'll just have to take my word for it. It is very, very quick. And the number of devs that spin stuff up every day, this can make or break, how productive you are. It has great support for the CLI. Yep.
Sorry, just a quick question. What's the biggest slow point at startup?
Probably a combination of the JVM kicking off and just the basic initialization. I think it connects to the database when it starts up. That might have something to do with it.
Is there a steep validation going on?
It doesn't do migrations when you start it up. You have to run that as a separate command, but it does, I think, connect to the database and check all the health checks. Yeah. So you'll get an error, for example, if your database isn't started and you kick it up. Yeah. Debugging is very, very easy. So you don't have to actually configure a remote debugging port or anything like that. Basically, you run it in debug mode and you can just hook in directly. So there's no separate Tomcat instance or anything like that. It's all built into the jar. So testing it. Testing wasn't really that different to any other Java project I've worked on, except for not using dependency injection. So what we ended up coming up with was a combination of unit tests with JUnit and Mockito, which you're probably all familiar with, and REST-assured. So REST-assured is a library for testing JSON APIs, but the difference is it tests it as a third party like a black box. So it hits stuff over the wire on your server and validates things like JSON and status codes and stuff like that. We also did some JSON schema validation. That worked pretty well. And we ran the test using a H2 database. So we tested all our migrations and stuff and the API and all the API end tests with those migrations in the database. In terms of deploying it, we made a jar, not a war, so there's no more wars. It's a very small artifact. It's only about 27 megabytes when you've got just a small project. Obviously, that'll grow a little bit, but 27 megs is a lot smaller than most of those Maven projects you've used in the past. Database migrations, Liquibase. I really like Liquibase. I've used it at a few companies now. It has a little DSL for writing SQL. You can sort of work with different schemas like Oracle or Informix or Postgres. And it just tightens up, it answers a lot of questions about how to deploy stuff and get the database migrations right. So to run the app with the artifact, that's all you have to do. So if you've got the artifact here, app.jar, server is the command on the CLI, and production.yml would be a YAML config, similar to Spring Boot, that has a bunch of settings and configuration on how to run the app. So what are some learnings? So we've been using this now for 6 months. We've learnt to separate API tests and workflow tests. So you might have a test that tests a single endpoint, and you might want to have a few tests that test a whole journey of endpoints. So creating a user, changing a user, and customizing all that sort of stuff. So we've ended up with different packages for that. We've separated views and our database model POJOs. Some people don't like DTOs, some people do. I think in certain circumstances, view POJOs or DTOs work well when the database model doesn't fit. So because you're using JDBI and not Hibernate, we found in some circumstances you do need to reread from the database. So let's say you do an insert using a DAO. You then have to reread it from the database as a separate command if you're returning that data in the response to the web layer. That's something that's not always obvious to developers. Liquibase, at least how it's implemented with DropWizard, requires an artifact rebuild. So if you specify your migrations and then you package it up and then you want to change your migrations, you have to rerun a build before you can execute those migrations. Otherwise, it'll just use the old config. So that was a little bit of a gotcha. We've used Gradle, I think, now to sort of do that auto-magically for us. So what are some strengths of DropWizard? It's productive and simple. It's really, really good to get started. It feels nice and clean, and it doesn't come with a lot of the overhead that I've seen on standard projects. We were up and running, I think, in 1 or 2 days. In a lot of Spring MVC apps, we tend to spend maybe a week doing all the configuration, setting all the versions of the jars, and all that sort of stuff. You can build it up as needed. So we've added a few libraries over time. We've added some stuff around JSON, and we've added Mockito recently. And you can also add Hibernate and Spring DI and Spring Security. So there's no reason to necessarily buy into that from the start, and you can add it where you need it. It's very fast and it's performant. I'll go through the performance in a sec. But even just to work with as a developer, it's very, very quick, and it's the best experience I've had to date in Java land. It's got really good ecosystem support. The open source community is rampant with extending it and offering modules and plugins and stuff like that. It works really well with Gradle. And JDBI keeps SQL transparent. I'll show you an example. This is basically how JDBI looks. So it reads very much like SQL, and it does do some nice things here, like bindings of parameters in there to avoid SQL injection. And you can do, I think it's like bind object or something like that, and it'll just splat all the values from a class into the query for you. Overall, I think it's a great choice for small or microservices. If you wanted to build one great big monolith for a large-scale product, it may not be the best choice. If you're going to use DropWizard, I'd probably suggest decoupling or decentralizing them into different concerns. So there's some weaknesses with DropWizard too. It has a lack of batch inserts with JDBI if you want to get the IDs out. So this wasn't really a concern for us, but we were surprised looking at the JDBI docs that there wasn't a mechanism to do this automatically. There may be ways to customize it. We didn't look into it. Multi-resource transaction scope is kind of tricky. So if you think of a resource like a user or an item in the database, if you have things that want to modify both of them in different services, by default we couldn't find an easy way to span those two services and have a transaction to roll back. We found you had to do it in a single DAO because that's the transaction level DropWizard has. That might have changed with a newer version, and you can customize it to have specific queries for that. But we found that a little bit inflexible, but at the same time it kind of forces you to have a clean model and a clean separation. So yeah, your separation of resources. Your resources in DropWizard are basically controllers. So you need to consider URLs as part of the design as well, because at the top of a resource you specify a base URL for all of those following endpoints. And like I said, there's no out-of-the-box dependency injection. This really doesn't matter to me personally. Some people miss auto-wiring. You can also include Juice by Google or Spring DI. So but given that, it has less support out of the box for Camel and RabbitMQ libraries because these kind of things leverage Spring and that ecosystem a bit more.
So can I ask, so how would you do the testing then? How do you separate your objects when you don't have the dependency injection?
It's hard to answer in one answer. I think at the end of the day, by keeping things simple, you don't really need a lot of dependency injection. And that's really about your sort of design choice at the start. When you just define what your tech stack's going to be, do you have one great big API, or do you have a few different ones for different concerns? If you had one great big one, you probably find yourself wanting DI a bit more. But at the same time, your test probably shouldn't pull everything in because you should be testing certain things at certain times. So I find that forces you to keep your tests and your code a bit cleaner.
Okay, because I would think that in your unit testing you take one class and you mock out everything else. If you want to mock it out, you need dependency injection. Right?
No. So you can use Mockito without dependency injection quite easily. So performance. So I've got a couple of stats for you. So we profiled Rails, Spring Boot, and DropWizard under proper test conditions. So ran them all on the same machine, all clearing the database and restarting the box. And these are the results. So the most important one that I care about is the 90% response time. So this was run for 3 minutes under load of 100 concurrent threads using JMeter, and we ran each test 3 times. And these are the averages. So Ruby on Rails got 35 seconds average, DropWizard got 2.5 seconds, and Spring Boot got 4.5. The CPU was a little bit higher in DropWizard, but it's much of a muchness, and the memory was slightly less. But overall, the 90% response time kind of made it a good choice. And that's it for my presentation.
How do you implement the logging aspects of the DropWizard application?
The logging
Yeah.
or login?
Logging.
Sorry.
So basically, if you run this container,
Yep.
you make a separation of the application runtime.
Yep.
So when you run it as independently, how do you manage the logs in your application?
Yep, so this runs as a Jetty server without any sort of web container. We had a different API at a different level to do authentication and authorization, so we didn't need to do that at this layer. Yep.
What about monitoring, like and health checks?
Yep.
Does it provide any views, web views, or because there is a JT app inside it?
Yep.
So, how did you do anything, or did you use some third-party tools? Or?
No, so it comes by default with a health check mechanism built in. It's actually quite good for testing databases, checking connectivity, downstream dependencies, and all that sort of stuff. And that's built into the framework itself. It's just a JSON endpoint that you can hit. It's documented on their website.
What about performance? Like, for example, how is it possible to measure GDBI calls, like to the database? For example,
Yeah.
I used like a Java melody, for example. It's
Yep.
pretty easy to use it.
Yep.
And did you know?
I know of Java Melody. I haven't used it with DropWizard, but DropWizard supports JMX connection, so you could do all the similar stuff you do normally. And I'm sure with logging and a bit of profiling, you could record that stuff. I personally like New Relic for all that kind of stuff, but yeah, each to their own. It does give you quite a lot of good info on each endpoint for metrics, things like average response time and all that kind of stuff, and that's built into the framework, so that's a good feature you get for free. Up the back?
What is the advantage of this over Spring Boot?
I don't know. It's hard to say. Like, it really depends what angle you're coming at it from. I think, to the other guy's point, if you want things like login, authentication, if you need to support Spring Security, if you're doing things like LDAP, you might be more inclined to go Spring Boot because there might be a bit less friction between the frameworks and stuff. Or you could just separate them out and have, you know, one DropWizard doing authentication, one DropWizard doing something else. There's no right or wrong answer, but you can always build up a DropWizard app to include other modules as well. So it's not like you can't do authentication in DropWizard, it just doesn't come with it by default.
Is it based on the servlet spec? Are you deploying in servlet, or is it
I can't remember.
Isn't it Jetty?
It's Jetty.
so there's still a servlet. There's still a servlet. The WebXML and everything.
There is, but it's like 5 lines of code.
Yeah, that's
Yep.
But at least you can still plug into what you know.
Yeah, exactly. Yep.
And also, if you are removing the dependency injection from your application, basically that means each and every aspect of every user story, you end up with the URL, or how you going to manage that kind of complex user story.
Sorry, how can you test the complex user stories? So what we did is we defined a bunch of fixtures separate to the code itself in the test, and basically they would hit each URL and you know, either pass in some data and do an assertion. So we reuse those fixtures, kind of like how you do it in like a Selenium-based test or an API test, and we just construct multiple steps out of those individual API tests and just create a user journey that way.
So what happens at the end of the day, that means you are end up with a lot of URLs related to each and every test cases, or so all the user cases also you end up with a lot of URLs. Is it going to be the conclusion, or how you would basically handle that?
How do I handle the URLs?
Yeah, because that means because you are removing the dependency injection, and
Yep.
and all that means each and every user story basically you get a separate URL. That's what I understand.
Well, yeah, if you construct a user story and the user's logging in and you're creating something and you're checking out or paying for something and whatever, there's multiple endpoints you'll hit, yeah.
So what happens if you get 100 or 200 or kind of that type of thing? So that means at the end of the day you get a lot of kind of URL, your repository kind of thing. You have to maintain a lot of URLs to just maintain each and every of them.
Not really. I mean, it hasn't come up as a concern. I guess if you're smart about it, you can use constants or static declarations in Java to mitigate that. But your tests are only going to be as complex as your code, or a little bit more, right? So as your code grows, your tests are going to get bigger and bigger, and that's just natural occurrence.
Is it similar to the Play framework, where because that doesn't have a very DI-based approach either, and
Yeah.
it does tend to be just basically do more or less integration tests, like you're hitting endpoints and doing, and then the problem behind Play is it's basically how do I get my I need a routes file so that I can respect the routes, so
Yeah.
my tests against the routes.
Yeah.
Programmatic so things don't break. Decide I want to move the endpoints around and things like that.
Yeah, I mean, it's kind of nice that this framework lets you test stuff from the API to the database and back as fast as it does. So there hasn't been a real need to do multiple levels of unit testing. Some core business logic kind of needs it, but they run very, very fast compared to hitting endpoints and talking to the database. But yeah, we haven't really cared much about dependency injection. It's more just a creature comfort. And you find with constructor injection, it's obvious what you're doing anyway. It's just replacing an annotation with a constructor parameter.
Why did you choose DropWizard
I used Play framework when it was like version 2.1. I haven't looked at it much since. I think the big difference was we didn't have enough expertise in Scala when we even looked at this, so it wasn't really on our radar. Scala was probably a bit more edgy for the team than Java. I think Java was a good middle ground. I mean, you could probably use Java with Play, but do people do that? Yeah?
It's going to get better in 3.
Okay, maybe we should take a look. All right. All right, great. Thanks a lot.